In this question here, we have some height of trees with their frequencies, and we're told to draw a histogram. Whenever I have a histogram question, I think about a rectangle, which represents the bar that you normally get on a histogram graph. The x-axis is always the class width. The y-axis is always the frequency density, and if I multiply them together, I get the area of the rectangle, which is the frequency. From that, I can make a formula triangle. I know that the frequency equals the frequency density times the class width. So if I'm looking for the frequency, I cover up the frequency and I know that is frequency density times class width. If I'm looking for the frequency density, I know that is frequency divided by class width. And if I'm looking for the class width, I know that is frequency divided by frequency density. In this case here, I have the frequency and I have the class width. The height is the class width. So to find the frequency density, which is the one piece of information I'm missing, I need to do the frequency divided by the class width. So my frequency density for heights between 0 to 2 is going to be my frequency, 7, divided by my class width, 2, which is going to give me 3.5. For the second one, I've got 14 divided by my class width, which again is between 2 and 4, which is 2, and that will give me a frequency density of 7. For the next one, I've got 18 divided by 4, which is going to give me 4.5. Then I have 24 divided by 8, which will give me 3. And for the last one, I've got 10 divided by 4, which will give me 2.5. Those are my frequency densities. So I know my frequency density is going to go all the way up to 7. In my histogram graph, I have none of the axes put into place. I know that the x-axis is my class width, which is going to be my height in meters, and the y-axis is going to be my frequency density. But again, I've got no scales on it. So in this case here, I'm going to put my number 1 5 squares up, my number 2 another 5 squares up, and then similarly with 3, 4, 5, 6, and 7. For my class width, I've got to make sure that I've got a height of 20 meters along the x-axis. So halfway, I'm going to call that 10 meters, and then to the end, I'm going to go 20 meters. So halfway of that would be 5 meters, and then halfway of that would be 15 meters. That way I've got all my scales covered on both the frequency density and the class width. For the first one, my class width is 0 to 2. For my scale along the x-axis, every 3 squares is 1 meter. So for my class width, I need to go 0 to 2 meters. So I need to go 6 squares along, and I've got to go up to a frequency density of 3.5. My next class width is between 2 and 4, and that has a frequency density of 7. My next class width is between 4 and 8, and has a frequency density of 4.5. My next class width is between 8 and 16, and has a frequency density of 3. And the final class width between 16 and 20 has a frequency density of 2.5. Here's a question for you to have a go at. Press pause and we'll run through the answers and the graph in just a minute. If you remember your formula triangle, we know that the frequency density is the frequency divided by class width. So to find my frequency density for the first one, it's 4 divided by 10, which is 0.4, then 8 divided by 5, which is 1.6, then 24 divided by 5, which is 4.8, 16 divided by 10, which is 1.6, and finally 5 divided by 20, which is 0.25. You now have to draw these onto the graph below. If you draw the scales and the histogram out, this is roughly what it should look like.